Pre-statistics. Graphing exponential functions, Part 2. Lesson objectives. Sketch the graph of an exponential function by hand and using a graphing calculator. Explain how the values of a and b affect the graph of f of x equals a times b to the x power. State the base multiplier property, the increasing or decreasing property, and the reflection property. Intercepts and the graph of an exponential function. Warning: exponential function of the form y equals b to the x. The y-intercept is not 0b. By writing y equals b to the x equals 1 times b to the x, we see that the y-intercept is 0, 1. For example, for y equals 2x, the y-intercept is 0, 1. Example 3. Let f of x equals 6 times 1/2 to the x power. Find the y-intercept of f. Well, we can see that the value of a is 6, so the y-intercept is 6, and the point would be a 0, 6. Example 4. Find the x-intercept of f. Solution: by the base multiplier property, x increases by 1, y multiplies by 1/2. So when x is 0, y is 6, the y-intercept is 6, and as x increases by 1 unit, the output is cut in half. So no number of halvings will result in 0. You take a positive number, you take half of it, you're left with a positive number. Take half of that, you're left with a positive number. You will never get 0. So as x gets large, y gets closer and closer to the x-axis. It gets closer and closer to 0, but it never does equal 0. This is called a horizontal asymptote. Example 5. Graph f by hand. So if we plot the points from our table, we see that the function is decreasing. It gets closer and closer and closer to the x-axis, but it never does touch it. Viewing this on the graphing calculator, we see as x increases, y gets closer and closer to 0, but it never does touch it. What's the domain and range of this function? The domain, again, is all real numbers, and the range is all positive y values. This function is increasing nowhere. This is a exponential decay. Whereas the function decreasing everywhere, all real numbers. This function is positive for all values of x because the graph is only in quadrant 1 and 2, and thus it is positive everywhere, all real numbers, and negative nowhere. Let's do another example. Example 6. Sketch and compare the graphs of f of x equals 5 times 3 to the x power and g of x equals negative 5 times 3 to the x power. Solution: we first want to construct a table of values. We pick the x's and we substitute them in to get the outputs of each function. When x is 0, f of x is 5, and for g of x, it's negative 5. When x is 1, we have 15, because 3 raised to the 1 power is 3 times 5 is 15. For g of x, x is 1, so we have 3 to the first power times a negative 5, which gives us a negative 15. So if you look closely, the values of f of x and g of x are just opposite. So we call g a reflection of f across the x-axis. Let's look at it visually. The blue function is f, and g is red, and we can see that this is a reflection across the x-axis. So the domain of f would be all real numbers, and the range of f is all positive real numbers. Now the domain for G, again, is all real numbers. Every X has a spot on this red graph, but when we do the range, is all negative Y values, because this graph is only in quadrant 3 and 4. So when A is negative, it is a reflection across the x-axis, and the range will be all negative numbers. When A is positive, the graph will be in quadrants 1 and 2, and the range will be all positive Y values. Reflection property. The graphs of f of x equals negative a times b to the x power and g of x equals a times b to the x power are reflections of each other across the x-axis. Illustration. For all exponential functions, the x-axis is a horizontal asymptote. The range of the exponential function f of x equals a times b raised to the x power is the set of all positive real numbers if a is a positive number, and the range is the set of all negative real numbers if a is a negative number. For both cases, the domain is all real numbers. So let's look at this graph. In this case, b is greater than 1. This is an increasing function. And a is also greater than 1 because it's in the first and second quadrant. Now if b is still greater than 1, but a is negative, this is now a reflection across the x-axis, and a is a negative number. For the case where we have a decreasing function, where b is in between 0 and 1, here's our value of a. It's positive, so it's in quadrants 1 and 2. And here is the graph of when a is negative. So we have an increasing function, or it could be a decreasing function. So it depends upon the value of b and also the value of a. Here we have a decreasing function, but if a is negative, it's flipped down and we have an increasing function. Example 9. The graph of the exponential function f is shown. Find f of 2. So we want to find what is the output of this function when the input is 2. So when x is 2, what is the y value on this graph? And it turns out to be 8. So f of 2 equals 8. Number 2, find x when f of x is 2. Now if you remember, this is our output, this is our y value, it's 2. So we go to the y, we find 2, and we want to know what x corresponds to that 2. Well, the answer is negative 2. So when x is a negative 2, f of x equals 2. Example 11. Find x when f of x equals 0. So we go to the y. Here's where y is 0. And we want to know what x will it be when y is 0. Well, this x-axis is a horizontal asymptote, so this graph will get close to 0, but it'll never equal 0. So there are no values of x where f of x equals 0. Thanks for watching.